Hello, Math 150. Today we're going to be looking at section 3.4, and our first objective is to find the domain of a rational function. Now, two things you got to know before we get started with this one. Number one, a rational function. So let's start with that. We've got a expression right here. This is the definition of a rational function. Here's the bottom line. Rational function, ratio, we're talking about fractions when we say ratio. A rational function is a function where the numerator and the denominator are both polynomials. So all those expressions we were dealing with in the last section, that's what we're talking about, polynomials. So as long as the numerator is a polynomial and the denominator is a polynomial, you've got yourself a rational function. So when you're talking about the domain of these guys, you need to keep in mind your three bad things that we talked about. So the three bad things again, number one, we can't divide by zero. This is bad news. Don't be trying to divide by zero. Number two, you cannot take the even root of a negative number. So that's bad news. Problems in your domain will come from that. And number three, something that we'll talk about in the future, not responsible for it now, we can't take the log of a number that is less than or equal to zero. So again, don't worry so much about the third one, not that big of a deal right now. We'll get to that in, I believe, chapter 4, when we're going to talk about logarithms. Okay, maybe further down the line. As far as rational functions go, which is the one we need to worry about, well, it's pretty clear to me that if a rational function is a fraction, then the number divided by zero is the one that we're worried about today. So all the problems we're talking about right now for finding domain come from finding out whether or not your denominator is zero. Keep that in mind. Denominator is zero. So we're going to jump ahead and look at the first problem for today, and that is find the domain of this beautiful function here. We got x squared minus 3x plus 3 over x squared minus 4x. If you are looking for the domain of this guy, okay, again, here's domain. That makes you think three bad things. That makes you think number divided by zero, negative number in a root, in an even root, or that third one, which is that logarithm thing that we're going to worry about in the future, okay? Again, I am telling you, for this entire section, we are talking about the one that takes us to a number divided by zero. So the key word here is basically finding out when the denominator equals zero. So all this is background knowledge to say we're ready to start this problem. To find out the domain of this function, what you're going to want to do is you're going to want to take your denominator and set it equal to zero. Okay? Throughout this entire unit, the key to solving these equations is going to be whether or not you can factor well. You're always, always, always going to look to factor. So as we go through this problem, I see a degree 2, I think factor. This is a greatest common factor. Both of them have an x in it. We're going to pull out the x. We're going to get x times x minus 4 equals 0. So again, we're just trying to find out where this denominator is equal to 0. So that took us to this equation, and now we're factoring. From here, each factor must get set equal to 0 separately. So we're going to get x equals 0 and x minus 4 equals 0. And that tells us that these two values, x equals 0 and x equals 4, these are the bad values. These are the ones that make the denominator 0. So in terms of finding the domain, we actually want to say that x can't equal 0 and x can't equal 4. If you think about this in terms of a number line, what we're doing is we're saying that 0, goodbye, you're getting the boot, and 4, you're getting the boot. So those two values need to be eliminated from our answer. So we need to get rid of them. So answering this in interval notation, x is going to start at negative infinity and continue all the way to 0. We're going to have another interval that goes from 0 to 4, and then we're going to have another interval from 4 to infinity. Infinities always get parentheses, and because these guys make a 0 in the denominator, the 4 and the 0, those guys are going to get kicked out of the domain. So our final answer here using interval notation is negative infinity to 0, 0 to 4, and 4 to infinity. So that is the domain. So again, take-home message is this. If you're finding the domain of a rational function, set the denominator equal to 0, and then kick out the values that make it equal to 0. Let's look at another example. In this one, we're finding the domain of another rational function. And again, the only thing that can go wrong here, according to our domain, the only thing that this problem has is we have to find the numbers divided by 0. And that is going to be standard on rational functions. It's always going to be the case. So we're going to take this guy right here, this denominator, and we're going to set it equal to 0. So the equation we're going to get is x cubed minus 4x squared minus 12x is equal to 0. This is a degree 3. We're going to take out the greatest common factor of x in this problem. And when we do, we're going to get x squared minus 4x minus 12. And now we're looking for factors of negative 12 that add to negative 4. Keep the x, don't forget about him. But now that trinomial gets broken up into x minus 6 and x plus 2. Those are the factors of negative 12 that add to negative 4. Once you're here, set each factor equal to 0 separately. So we're going to get x equals 0. This is going to get us x equals 6. And the last one's going to get us x equals negative 2. Remember, though, these answers are really like the anti-answers. They're the bad things, so we've got to kick them out and write our final answer using interval notation. Again, we're going to start at negative infinity. The first place we have trouble is negative 2. Then we're going to start at negative 2 and go to 0. Then we're going to go from 0 to 6. And then we're going to go from 6 to infinity. Again, all of these are going to be parentheses because the zeros cannot be included when we're talking about using the denominator. Okay? So and again, I like to show you this visual. I think it makes a lot of sense. When we put these on the number line, we're saying negative 2, 0, and 6. So when you look at this, you can see there's one interval here, there's one interval there, there's one there, and there's one there. So there are 4 intervals, and that is why we have 4 answers. Each interval matches up to one of the answers. So the take-home message for this first one is when you're finding domain, denominator equals 0, then you factor and you solve. I hope those make sense. Oh, actually, before we go, we're going to do one more question. One more with you guys today. All right. So this is one that is a bonus one. You get an extra one from me today. F of x equals 3x plus 2 over x squared plus 10. Okay. So if I want to find the domain on this one, again, domain, the only thing that can go wrong is the denominator equals 0. So we take this equation and we set it equal to 0. Now, this equation gets a little tricky because if I try to factor this, none of our methods of factoring work, okay? Nothing we have is going to work on this one. You could try the quadratic formula. You do have an a value of 1, a b value of 0, and a c value of 10. But I just want to appeal to your common sense on this one. Here's what I want to think about. I know that x squared cannot be negative. So the smallest x squared can ever be is 0, and it can never be negative. So if I'm taking a positive number or 0 and adding it to 10, there is no way I can get 0 for an output. If you try to solve this, you're not going to find a solution because there are no solutions to this equation. And what that means is the denominator can never equal 0, ever. So that means no matter what we plug in, it's going to work. So in this case, the domain is going to be, thinking about the drawing of the number line, it's going to start at negative infinity, it's going to go to infinity, and nothing's going to break it. So our answer for this one is the domain goes from negative infinity to infinity. And that would be our answer for this one. That's perfectly okay. You don't have to have any domain problems in a rational function. Most of the time you do, because most of the time we can find a solution. But if you're doing a problem and there's no solution, don't be afraid to put all real numbers, negative infinity to infinity, okay? One last thing about this, notice I never touch the numerator in any of these problems. The numerator is completely irrelevant. The answer will always come from the denominator. So regardless of what the numerator is, you don't have to work with it. There are a bunch of homework problems from this section on practicing domain. Give them a shot. If you need any help, you can reach me at my office hours on Wednesday or Thursday this week as stated in the syllabus. Other than that, reach out to me anytime through email, and I hope you guys are doing great. I'll be back soon with the next learning objective from this section.